Let us prove the vector identity Laplacian fg equal to f Laplacian g plus 2 gradient f dot gradient g plus g Laplacian f. To prove this, we have to first find out what is Laplacian fg. Laplacian fg can be written in your del operator like del of fg. Then what is del of fg? Del of fg will be equal to, this is your del operator, that is I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z, and f and g are two scalar functions. So what will be the, if you take the partial derivative of these two scalar function with respect to x, then that will be equal to I cap partial derivative of fg with respect to x. Similarly for y component, j cap partial derivative of fg with respect to y plus for z component it is k cap partial derivative of fg with respect to z. So if you, this is a product function, so if you find out the partial derivative of the product function, then that will be equal to I cap first function derivative of the second, that means f partial derivative of g with respect to x plus second function, that is g, and partial derivative of f with respect to x. Similarly, we can find out the partial derivative of this product function. So j cap partial f into partial derivative of g with respect to y plus g into partial derivative of f with respect to y. Similarly, for the z component, we have k cap, and then the first function derivative of the second, that is f partial derivative of g with respect to z plus the second function, that is g partial derivative of f with respect to z. Here you see you have two functions. One is your g, this is g. Here also you have g, and here you have g. And you can take common f in three functions. F is multiplied, so you take f common. If you take f common, then partial derivative of g with respect to x, and from this partial derivative of g with respect to y, and from this partial derivative of g with respect to z, and you have I cap, j cap, k cap. Similarly, for if you take g common from the f function, then that will be equal to I cap partial derivative of f with respect to x. Then from this you have j cap partial derivative of f with respect to y plus k cap partial derivative of f with respect to z. So we have found out that the del of fg is equal to f del g, that is your gradient g plus g gradient f. But we have to find out the Laplacian fg. So Laplacian fg, that is equal to del dot the del of fg, and we have found out del of fg is equal to this much. So if you substitute this value here, then this will be equal to del dot f gradient g plus g gradient f. If you simplify it, that will be equal to del dot f of gradient of g plus del dot g of gradient of f. Okay, here you see what you have found out here, this one. Okay, this is nothing but gradient of g, and this is nothing but gradient of f. Okay, that is why the gradient of fg is equal to f gradient g plus g gradient f. Then you substitute this value here and you find out here. So this is equation number 1. Now we will find out what is the value of this and what is the value of this. Now what you do, you apply product rule. We know applying product rule, del dot h is a scalar and a is a vector, that will be equal to del h, this is your gradient, this is your gradient h dot a vector plus h Then this is your divergence, del dot A. Suppose you put A equal to del G, that is gradient G, and your F is equal to, H is equal to F. Then what will be, applying product rule, this rule, what will be the answer? This will be equal to del dot F A equal to grad G. So grad G, that is equal to, if you apply this rule, then del F dot del G plus F into del dot del G, and that is equal to F of Laplacian G plus del F dot del G. Suppose this is equation number 2. Similarly, if you put A equal to del F, and in this product rule, and H is equal to G, then what will be your result? The result will be del dot F del G del F, that will be equal to del G dot del F plus G del dot del F. You put here A equal to del F, and you put H equal to G, then that will be equal to G Laplacian F plus del G dot del F. Suppose this is equation number 3. Now you put the result of equation 2 and 3 in equation 1. So Laplacian Fg will be equal to F del square, or Laplacian G plus 2 del F dot del G. This is gradient F dot gradient G plus G Laplacian F. So this is a very useful identity. You have to remember this identity, which is useful in various problems in physics.